These are the lesson 3 practice problems, and you're supposed to do a translation of this image, a reflection of this image, and a rotation of this image. So first, the translation. It's going to move this figure A from point B to P to point P prime. Remember, the prime means it's the corresponding point to the original point, which in this case is P. So this one's a little bit tough to do because you're sliding or you're translating this figure in a horizontal direction, so directly horizontal across. So it's hard to count, it's hard to see that. So I use these dots. So this is 1 unit, 2 units, 3 units, 4 units to get to P prime. And to move this point, those same number of units, I'm going to count once again. 1, 2, 3, 4 to get to this pink point here. And so these 2 points move 4 units to the right. The back unit, I'm going to move from here to this point right here. So I'm going to count once again. 1, 2, 3, 4. So 1, 2, 3, 4 lands right there. And the last point is going to go right here. So I'm going to count again, 1, 2, 3, 4. So this is a translation. All the points on the figure move in the same direction and at the same angle. In this case, it's a 0-degree angle. It's not turning or changing at all. So 1, 2, 3, 4. And there it is, translated to the right. Okay, rotation. So you're going to rotate this image A 60 degrees. We're doing this on isometric grid paper. And so almost always you're going to look at a 60-degree rotation. I think just one time have the authors asked you to rotate an image 90 degrees. But most of the time it's 60 degrees. And so this is a 60-degree rotation from this side here to this side right over here. And you can check that it is a 60-degree rotation by using this counting strategy that I've shown you how to use. So if I count, I want to get to this point right here. So if I count along the side of the triangles, this is 1, 2 units, and I'm going to rotate 60 degrees, and I'm going to count 1, 2 units. So this point here lands here at this point. This point here, I'm going to count over 1, 2, and then I'm going to count in the direction of rotation 1 unit. So this is 1, 2, and then 1 unit in the direction of rotation. So I'm going to rotate 60 degrees, and I'm going to go from here to here. I'm going to count 1, 2, and 1 unit in the direction of rotation. And this point right here, this is just 1 unit along this side of this triangle. I'm going to rotate this 60 degrees, and it's 1 unit along the side of this triangle. So this point goes to here. So all the points line up after a 60-degree rotation. So that rotation is correct. And finally, a reflection over this line L. When you talk about reflections, think about connecting the corresponding points by drawing a line perpendicular to the line of reflection. So that's another word, that word perpendicular, I have to continue to get used to. That means a 90-degree angle. So if I have line L, a 90-degree angle is going to be from P, and I should label this actually should be labeled P prime. This P prime is for that translation that we did earlier. All right, so I'm going to draw the lines from P to this point. This is perpendicular to line L, and it's the same distance on the other side of the line of reflection. So this is 1 unit, 1 unit. This one is 1, 2, 3 units, 1, 2, 3 units to get to here. This point is 1 unit and 1 unit. And this point is 1, 2, 3 units, 1, 2, 3 units. So how do I know where to place them? I have to draw that line that's perpendicular to line L, and just count the number of units. It's the same on one side as on the other side. So that is a reflection. So you reflect it over and you get this image right here. Now if you did some coloring, you could probably get a nice optical illusion by coloring in these faces and trying a couple of different ways to do that. All right, this one's pretty tough. This is a rotation, a 90-degree rotation. This is problem number 2, and it's your choice how you want to do this. And I chose to rotate this figure around this point right here. So I'm going to break this up and show this to you in pieces because it's really messy to look at like this. But first of all, I'm going to tell you that my choice for the center of rotation is right here. So I am choosing that. I'm saying this is going to be the point around which I'm going to rotate this image 90 degrees. And what that means is I can draw a 90-degree angle from A to A prime. So it's going to rotate 90 degrees. Now, how do I know that's 90 degrees? I'm going to show you that in a little while. But that means I can also draw a circle with the center of that circle at this point, which is the center of rotation, and A prime will be on that circle. I can also draw a circle for B, and B prime has to have the same center of rotation because this image is rotating around this center of rotation, this point right here. And C, the same thing. I can draw a circle with the center at this point, and C prime have to be on that circle. So let me zoom out for a moment, show you the whole thing. This is the circle for A, the pink, the blue is the circle for B and B prime, and the red is the circle for C and C prime. And the point is that they all have the same center of rotation. It's at that same point right there. All right. So I'm going to go through some steps on how to locate this center of rotation. What if I didn't tell you that it's right there, but you wanted to find out, you wanted to figure out where that center of rotation is? I'm jumping ahead a little bit. There's a separate video for this in lesson 4. I'm just going to introduce some terms and show you how. It's not a big deal. And the words I'm going to use, I'm going to connect the corresponding points with a line segment. So I'm going to draw a line segment from A to A prime. I draw a line segment from B to B prime. So I'm going to connect the corresponding points, C to C prime. Then I'm going to find the midpoint of those line segments. I'm going to use Doceri to do that. I'm going to show you in just a moment. And then I'm going to draw a line, a perpendicular line from that midpoint. And for A to A prime, it's going to intersect at this point. From B to B prime, it's going to intersect at this point. And from C to C prime, it's going to intersect at this point. So the words, draw lines that connect the corresponding points, find the midpoint of that line. I can use Doceri to do that. And then draw a line that's perpendicular to that first line segment. A lot of words. It gets a little bit tough to follow, but that's okay. So here's the video. So the first thing I'm going to do is connect A and A prime with a line. Then I'm going to use Doceri. And the nice thing about Doceri is if I draw a line segment and I just start searching along that first line segment, it will snap to the midpoint. So that midpoint is actually at point B. And now I'm drawing a line that's perpendicular. So I'm searching right now. It has to be a point that intersects on the grid because it's a 90-degree rotation. And so I'm looking for a point of intersection on the grid that forms a perpendicular line. And it looks like if I count over 2 and down, what is that? Over 1 and down 2, it looks like that's a perpendicular line. And we'll come back to that in a moment. So now I'm going to connect B to B prime. I'm going to find the midpoint. So I'm going to use Doceri to find the midpoint. This one is the hardest one to find the midpoint because it's not on the grid. It's not an easy way to count. So the midpoint's right there. And so again, I'm looking for a line that's perpendicular that's going to intersect. And it's right there. So forming a right angle. And finally, I'm going to connect C to C prime. That should be C prime down there. Get rid of that line. Connect C to C prime. Find the midpoint. Now this one you could just count from C and from C prime. I'm going to use Doceri. It's going to go right there. That's the midpoint. Now, since it's a vertical line, a horizontal line is going to be perpendicular. It's going to form a right angle. I'm just going to draw that line out. That is forming a right angle with the first line, the line that connects C to C prime. So where those three lines intersect, those three lines that are perpendicular to the first line, man, language gets pretty tough. But where they intersect, that is the center of rotation right there. So how do I prove to you that it is a 90-degree rotation? So I'm going to use that counting strategy. So in this case, this is just for A. I'm going to go to an axis. It doesn't matter which axis you use. This is the x-axis around this point. This is the y-axis. I'm going to count over on the axis 1 unit. And then I'm going to count 3 units in the direction of rotation. So 1, 2, 3. So I'm going to rotate 90 degrees. So I'm going to turn from this point here to this point. And I'm going to count in the same way once again. So I'm going to count along the axis 1 unit, and then in the direction of rotation 3 units. 1, 2, 3. And I do end up at A, and this should be labeled A prime. So once again, 1 unit and 3 units up, 1 unit and 3 units over, and I end up at the corresponding point. So if I do that same thing for B, I'm going to count along the axis, and then I'm going to count, so it's 2 units along the axis, and then 1 unit in the direction of rotation, and I'm going to rotate this 90 degrees. It's going to go to here. I'm going to count 1, 2, and 1 unit in the direction of rotation, and I do end up at B prime. So I end up in the correct spot. So it is a 90-degree rotation. So once again, 2 units, 1 unit over. 2 units, 1 unit down. Same thing for C. And I count along the axis 1, 2, 3 units. And then in the direction of rotation, 1, 2, 3 units. And I'm going to rotate this pink arrow down 90 degrees down to here. And count again. 1, 2, 3, 4. I miscounted. 1, 2, 3, 4. Yeah, 4 units. 1, 2, 3, 4. And then 1, 2, 3, 4. And I do end up at C prime. So all of those points, you end up at the proper spot. So it is a 90-degree rotation around this center of rotation, which is right here. Pretty tough. This is looking at the figure with all of them together, and it's just too messy to look at. Okay, translation of this image. So you have to move the same number of units over and then down. So this is 2 units over, and 1, 2, 3, 4, 5, 6 units down, 2 units to the right, 6 units down, 2 units to the right, 6 units down. And then if you color that in, you can get a prism. In this case, I think it's a right prism. I think these are going to form right angles if you tilted it over. Be a nice activity to go through. How can you tilt that over and make it look like a like the rectangles having right angles? But if you shade the bases, this is one base and this is the translated base. So that's what a prism is. The translation of one base to another place or another spot on the grid. And then you connect the corresponding sides, and these are called faces. So you have bases and you have faces. The bases are the polygons that form the bases, and the faces are always parallelograms, in some cases rectangles if it's a right prism, that connect the corresponding sides. Reflection. So you look at the line of reflection, and then you draw perpendicular lines that connect the corresponding points. This point corresponds to this point right here, And it's the same number of units on each side of that line of reflection. So you count over 1 unit and 1 unit. So this is a perpendicular line that connects the corresponding points. This is 1 unit, and it looks like a half a unit. It's a little bit tough. So this is 1 and a half, and from the other direction, a half and 1. So you put the corresponding point right there, and this one. This is 1, 2, 3 units. So you're going to count on the other side of the line of reflection, 1, 2, 3 units. Connect all these points, and if you shade this in, you could get some interesting optical illusions like I showed you before. All right, this is problem 3. And in problem 3, they give you this image, and you're supposed to translate it, rotate it, and reflect it. I made these images available to you, and I'm going to put that link in the information below this video. So the first problem, 3A, you're going to translate this pentagon from A to A prime. Actually, in the paper it says on the workbook it says from C to C prime. Same thing. So you're going to move this from here over to here, so it's all going to move in the same angle and in the same distance. All these points move over. Now if you shaded this in, this is one base and this is the second base. Actually, this is the first base, and then it gets translated to this base here. You shade this in and shade the faces in, which again are parallelograms that connect the corresponding sides. So side AE corresponds to side AE. And again, this should be A prime and E prime. So you could shade these in and show, in fact, that this is a prism. And it looks like it will be a rectangular prism as well. The reflection. So when you see the word reflection, think of the line of reflection. Think of drawing perpendicular lines that connect the corresponding points. So this line segment is going to go from here to here. It's going to be the same distance on each side. This line segment is going to go from A all the way over here. It's going to be the same distance on each side. So this distance matches this distance. And D, this distance matches this distance. And B, this distance matches this distance. This is a little bit tough to do in Doceri because we're not doing it on a grid. I would probably choose to do this on a grid, and I would ask you to do it on a grid if you were doing this problem. Same distance here to here. Again, the point is that all of these line segments are perpendicular line segments forming a right angle with the line of reflection. And the distance on each side is the same. So a little bit of creative coloring, you can get a nice optical illusion. Actually, this square, as I look at it right now, kind of flips back and forth without even coloring anything in. All right, this is a rotation 150 degrees. 150 degrees. I'm going to take this pentagon, I'm going to rotate it around this point C, 150 degrees. So in Doceri, you can actually import a protractor into Doceri. I'll make that available to you as well. And this image, and you can play around with this in Doceri. I'm going to show you a little video of taking this pentagon and rotating it 150 degrees around here. Now, a couple points to look for. I'm going to stop at 45 degrees, which is right here. I'm going to stop at 90 degrees, which is kind of covered up. 60, 70, 80, 90 degrees is about right here. And then I'm going to go to 150 degrees. So let's watch the video. So take a copy of that image. Just lay it over the top there. And now I'm going to twist it around. I'm going to turn it around point C, and I'm going to stop at 45 degrees. So that's about 40 degrees right there, and right there is 45. I'm going to expand it out a little bit so the size is correct. So that's a 45 degree rotation. So now I'm going to continue, and I'm going to go to 90 degrees, which is right there. It's a 90 degree rotation, then continue all the way around, and that's a 150 degree rotation. So I'll make these images available to you, the figures, and also the protractor, So you can play around with it on your own in Doceri.